Greetings, ladies and gentlemen. My name is Giedrius Kaveckis, and today I would like you to present our second research about the HAZ-MH and how we succeeded to internationalize the HAZ-MH flood model. I would like to start with the structure. First, I will introduce you the motivation why we are doing that, then the HAZU software itself. Then I will present you the problems which occurred to use the HAZ-MH internationally. Then the conception of the geographical divisions and what role do they play in HAZUS. Then the solutions and the requirements which are needed to achieve these solutions. And then goes the practical demonstration of our created tools, and in the end the conclusions, future work, acknowledgements, and the past presentations. About the motivation. Everyone knows that the floods are one of the deadliest natural disasters. And that's why in 2007 the European Flood Directive was signed between 27 European member states. And before there was the Water Framework Directive, but it was more focused on the flood defense and how to defend against the floods. While this European Flood Directive, it aims how to reduce the flood risks. And also European Flood Directive requires the European member states to deliver various flood risk outlooks like flood hazard and flood risk maps. And then the scientists started to search for efficient and cheap tools how it would be possible to deliver these outputs and to reduce flood risk in their home countries. So our focus was diverted to the HAZ-MH as a well-known and documented flood hazard mitigation software. It is quite used in the United States still. And the post-researches of Kulmish and Kaveckis' master thesis showed the potential use of HAZ-MH in the international area. Also such things like increasing quantity of volunteer geographical informations motivated us to search how it would be possible to contribute flood risk assessment. HAZ-MH, the abbreviation as Hazards US Multi-Hazard, is a free, powerful risk assessment tool for analyzing potential losses from floods, hurricane winds, and earthquakes. This software was released by FEMA, and it acts as ArcGIS extension. That is a very huge advantage because inputs and outputs you can process directly in the ArcGIS. But the problem is that originally this software, HAZ-MH, is designed to work only with US datasets. The focus of this presentation and this project is mainly on the flood model, but we hope that in the future this will also contribute the earthquake and the hurricane models. And HAZ-MH is still used for disaster mitigation response by many national and local US agencies. Without my mentioned types of disasters, HAZ-MH also supports the exposure assessment of tornadoes, tsunamis, landslides, and wildfires. Now about the over here in the left you can see the HAZ-MH flood model schema. Flood model assesses the direct damage to the buildings, facilities, and also the aggregated data like the vehicles, agriculture, or general building stock. This flood model also generates the summary of debris from aggregated building data and calculates the direct and indirect economic and social losses. And the damage assessment is performed by combining the flood depth grid with the inventory data like point and aggregated data, and each type of data has its own damage function. So it combines it and it delivers the results like damage estimation. Now about the advantages of the HAZ-MH flood model. This model, as I mentioned already, comes as ArcGIS extension. It also accepts the inputs from the hydraulic engineering center. Also it is well documented tool with a lot of tutorials and a lot of guides. Flood model takes the information from the inventory information from the common inventory, so it is also capable with other Hazus models. Hazus is constantly in development, and the newest version will show up in the spring of 2012. It will be 2.1 version, and Hazus contains the default US inventory data. Also, this inventory is centralized and can be managed from one central location, if example on the local area network. And this inventory enables to manage, store, split data. And as already mentioned, the flood model is well proved and quite often used in United States for flood risk assessment. And it's the model itself and the Hazus software, they are quite simplified for more simple user use, where user is not needed to put a lot of efforts to use it, so it's quite simple. And the big advantage is that it is freely available, and the teaching network of HazusMH is quite developed in the United States. There's a lot of courses, seminars, and HazusMH, as I mentioned already in the flood model schema, can perform flood risk assessment with the site-specific and the aggregated data. Now, because HazusMH is so wonderful tool, the question, of course, why it can't be used in the internationally. So practically, HazusMH analysis models don't care about where the data is from. The main problem is the study region, and right now, by default, HazusMH originally works only with US datasets. So it means that the study region can be created only in the United States. And this is the main problem. So you can't choose your study region outside the United States. And this study region is created from the administrative and census units. And so the hierarchical structure of state, county, census tract, and census block, which is used in Hazus, does not fit to worldwide standards. That's the main problem. The second smaller problem is the differences between the metric systems in the United States and the rest of the world. Now I will talk more about the main problem, the geographical divisions which are used to create the study region in Hazus. So over here in the image you can see the 4 geographical divisions which are used in Hazus. And as I mentioned already, they are to define the study region in HazusMH, and also they contain some needed data for the analysis. And each geographical division feature, like state, county, census tract, or census block, they are defined as geographical features, and together they contain the attribute information. And all the data are stored in the state inventory. So it means when you want to update, to insert new attribute information, you must call the state inventory and then to do modifications over there. And the most information which are needed for the analysis are contained in the census units. So it is census tract and census blocks. For earthquake and hurricane models, the main information is in the census tracts, and for the so as I mentioned before, the biggest issue is to find the alternative geographical division system which would be the same in every country in the world, and to interchange it with the geographical division system in Hazus. So what we found the same 4-level system, but instead of namings of state, county, census tract, census block, we named it level 0, level 1, level 2, and level 3. And we introduced the data set where user can choose any country of the world he wants to create the study region, and then the model gets all the information which are needed and creates the relation between the layers, and then overwrites it with the original HazusMH files, and then the user is able to create the study region. And also, if the user is not satisfied with our inputs, we define the possibility for him to create its own Geographical Division system. So it means that user can choose what should be level 0, what should be level 1, what should be level 2, what should be level 3. So it means this system is quite flexible, and the user can create its own resolution and the study region what he wants. Now it's time to talk about the main parts of the requirements. The requirements which are needed to create the study region, and the requirements which are needed to perform flood risk assessment. For sure, we will talk about the requirements which are needed to perform the actions worldwide. So first of them is to create the study region. In the slide before, I mentioned that the 4 different spatially and hierarchically related geographical features are needed. And if user wants, he can define as inputs its own features. But we also, I already mentioned that, we also introduce the data set which provides the needed inputs for each country in the world. And also, as a smallest area, the level 3, it is as a census block in HAZUS. We introduce the worldwide about 21 square kilometer grid with the population data. And for the flood risk assessment, the main inputs are inventory data, it's aggregated and site-specific data, flood hazard data, so flood depth grid, and it's needed to modify the damage functions. So first about the inventory data. In the earlier presentation, I presented how it is possible to use volunteer geographic information as Openstreetmap and import the user-defined facilities. Also, using the same framework, you can import the bridges or other transport facilities, or even the utility facilities. Today, in the practical presentation, I will present to you how it is possible to import the essential facilities using Openstreetmap, and everything is automated. You need only to select the extent and to save the results. Also, we provided the possibility to import such aggregated data as vehicles or the general building stock. I will show you also that in the practical presentation. And about flood hazard data, HAZUS itself, it provides the possibility to perform hydraulic and hydrological analysis inside the HAZUS. When talking about the hydrological analysis, the problem is that the regression equations are not provided over here in HAZUS for worldwide use. So right now it is possible only to perform the hydraulic analysis. So HAZUS generates the stream network, and the user can choose the reaches, and the input is required the discharge value. And then over there is Manning's I calculation, mathematical calculation, and HAZUS creates the flood boundaries, and then it can be used as a flood hazard data in HAZUS. Another possibility is which we introduced also in the previous presentation, is this subtract of the DAM from the flood elevation, and then you can get the rough flood depth grid. And the modification of the flood damage functions is possible through HAZUS interface as a default HAZUS function. And when these requirements are satisfied, then you can follow our methodology by using our tools, and in 4 simple steps you can create the study region and then later perform the flood risk assessment. Welcome to the practical part. of this presentation, and during this presentation I will show you step by step how to create the region for our interested area and how to proceed the flood risk assessment. So first of all, I'll start over here with a called Hazus, and I will show how it looks by default. Over here we have the HAZ-MH MR5 icon. Just click. And over here we can create a new region, what we will do now. Just create the test region, select the flood. An example, I will choose the census tracts. Over here you can see the list of all United States. Choose where we want. Over here you can see the list of Illinois state counties. Also you can choose it on the map, and you will see that the area is restricted. So we can create the region only in the United States, as I mentioned in the slides. And for this reason it doesn't fit to proceed worldwide analysis. Also, you can select multiple counties if you want. So here we go, we have the Illinois. You can select multiple if you want. Okay, so cancel that, and we'll try to change that. I would like to mention you that over here on my computer we have two operational systems, because the newest version Hazus 2.0 is not operational with my operation system Windows 7. And so over here I have the host on the virtual machine, the Windows XP and Hazus MR5, and over here I have on the RGS 10th I have my tools. And over here you can see the representation of the folder. The folder is the area where we stored our tools, and it is relative folder. So over here you can reallocate your folder wherever you want. It will work, and all the tools will work. And so over here we have the inputs, outputs, scratch database, scripts, tools, and a lot of other things. The important thing is for sure the MXD file. We can check it over here, and over here you have the toolbar with our created tools. I called these tools HAZ-I, Hazus International, and during this presentation I will introduce you all the tools step by step. Now in front of you you can see the schema, in which all the tools which were prepared are visualized, and also you can see the 4 main steps which are needed to successful integration of the study region in HazusMH. Without the main steps you can see many optional steps, like to prepare inputs from our created data sets, also prepare aggregated data and add aggregated data, also to download the essential facilities from volunteer geographic information systems, and also to prepare flood depth grid by using our methodology. Before starting the work, I would like to mention that at the beginning it's recommended to go to the geoprocessing and then geoprocessing options and check in the option add results of geoprocessing operations to the display. This will make our work easier. And right now, for the framework, we should start from the operation input source. And over here, as I explained earlier in the slides, we need 4 different features which are related between themselves. And so over here can be by the inputs by the user, or you can use our data set, which I will present right now, and I will use it in this presentation. Over here you can access the data set through this icon, and you choose the name of the country which you are in right now. let's leave over here the Lithuania as it is. So we will do now the region in Lithuania, and we will try to make the flood risk analysis over here. We just click on, and the model will create 4 different geographical divisions in our output folder. We finished to acquire the data from the dataset. So now let's check what do we have over there. So in the output folder we have 4 layers, geographical divisions. This is level 0, the shape of the country. Then we have level 1, level 2, and level 3. We can try to zoom in and check the information. So here we have aggregated information, the grid code, which we will use as aggregated data input for Hazus shelter analysis. So when we have 4 of these layers, now we can get back to the input source for the first one operation, and here should define the path to these inputs, to these 4 inputs. And when we define the path to each of the inputs, we just click OK, and the model will create another inputs in our input folder. From there it will be accessible to other Hazus models. And the second operation is to delete unnecessary fields, but because all the fields in our inputs are needed, so we will skip that and we will go further to projection operations. So over here, if your inputs are already in the NAD 9083 projection, you should choose this one, accept the inputs, or if they are not, you should choose this one. And we will choose the second one, and over here we will have to define the path. Advise that over here you will have to define the paths not to the original inputs, but the inputs in the input folder, in our folder where all the tools and HAZ-I MXD is located. When we define the paths to each of the inputs, as you can see over here, they are in the C drive Hazus implementation inputs level 0 and so on. And you have to choose the geographic transformation. Over here we choose from VGS 1984 to NAD 1983, and this are defined for all the 4 inputs. And then just click on, and then the files will be reprojected and copied to the Scratch geodatabase. The next step should be the integration one, this one. And right now, until the model is loading, this step is the most important, because over here are the most of the operations which creates the relations between our inputs. And do not pay attention to the first 4 rows. The more important are the 5th and the 6th row. Over here you should define the name of the columns which contain the name in the level 0 and level 1. And so according to the Hazus, over here should be the level, state level and county level, but because we use the input from our aggregated data set, so we will use the name of the counties in the level 0 and the name of the states in the level 1. So over here we have for level 0, yes, for level 0, as I remember, the column name is name ESOI, ISO, and over here name and 1. Before we click OK, I would like to inform that over here it's very important to write the names of the columns in the brackets, because if not, then the whole model collapses. And so when everything is fine, just click OK and the model will run about. It depends honestly on your input data. Example, for this Lithuania inputs from our suggested data set, my computer takes about 10 minutes, so during that time you can do something useful. After we finish our integration, if we are satisfied, the next step could be, and the last step could be, to prepare outputs. but because we have some kind of attribute information, aggregated population data from our data sets, so this operation what will be, we will prepare the aggregated data. This simple operation just does not require any inputs, it just allocates new tables which will be required for the aggregated data. So we'll just click it and then it will, and then after that we can choose general building stock, demography, vehicles, and so on. In this case, after that we will choose demography to add level 3, but I will show you more in details. Now we have to prepare the aggregated data. When we got the confirmation that our aggregated data is prepared, so we just close and we now will choose the demography to add level 3 demographic count, because our aggregated data population was in the level 3. So we'll choose this one. And over here you have the table and you can choose the fields which you will want to populate. So in this case what we have only the population, so we will choose one. This one, population. In this case, if you have more like male population, female population, white, and so on, even the income, you can choose another ones. And in this case, because we have only the population, so in the analysis we'll be able to get the results only of displaced persons. If you would have more parameters, like I mentioned, households, male, female, young people, information, then you would be able to define the shelter needs. But in this case, it is what we have, population. So we just select the field and click OK. And it will prepare the aggregated data from our input data. When we are finished with our aggregation, then we can choose another one operation. It's called prepare outputs. It's simple, takes the files from the usual location and copies to the output folder where they can be reached easier. And so right now I will close it and I will show you what are the outputs over here. Over here we have one output, we have the HAZUS folder which we will have to overwrite. And over here we can explore a little bit, like census block over here, and you can see all the information, all the relations which are needed for HAZUS. Also we got another one, aggregated information, and over here we can check the demographic count by block. So over here we have our census blocks and the grid code which is defined as a population and which we will integrate later. Right now our outputs are ready, but we want more. We want to integrate the essential facilities, and we will do that through the volunteer geographical information system, Openstreetmap. Before starting to work with Openstreetmap tools, I would like to mention that these tools are enabled only if you will download the S3 ArcGIS editor for Openstreetmap from S3 web page. This editor is free and it is capable with ArcGIS 10 version. By default these models comes quite simple ones, and over here we modify them a lot that they would be able to download only what we need. And so the first operation what we need is to show the extent of the study region, because the Openstreetmap tools are quite limited, so it's not possible to download all the data for all the country. It would be a huge amount of data. So you need to focus to smaller area, and for this case, to navigate easier, we will add the extent, and so it automatically adds over here. So you can see over here the extent of Lithuania. As I remember, there are census tracts, and right now, to make everything easier, we can add also the imagery. So over here we can choose one option from the ArcGIS, so we can add the base map. And choose the imagery. Next of all, we are focused on the specified Vilnius capital area, so we will zoom over here. So I zoomed to the area and I made the extent layer transparent, about 80%, and over here you can see the aerial imagery of Vilnius, the capital of Lithuania. And now we will do another operation. We will download essential facilities from the Openstreetmap. So here we click the model. Also, the imagery is quite good quality to identify the essential facilities, as example. And over here, it's very important, the most important thing over here in this whole is to select the extent of data download same as display. So it means that it will take the extent is the screen over here. And then when ready, just click OK, and then what the model do, it downloads all the extent and it filters all the information which is significant to us. And in this case, the essential facilities: schools, fire stations, police stations, and healthcare facilities. Finally, our model finished. And what do we have over here? We can see that Openstreetmap download all these essential facilities over here. What is nice option that automatically when it's downloaded, it's automatically visualized according these layers and this symbology. So over here you can see fire stations, hospitals, various types of schools, universities, and all these points are saved in the output folder in the OSM points folder. So in this case, everything is finished and we are ready to prepare to create the study region. Right now we will navigate from the main folder to the outputs folder, and over here we have the aggregated information, HazusMH with the Hazus files, and the OSM with the essential facilities from the Openstreetmap. So what we do need now we need to write these files with our HAZ-MH program file. So let's get back to the operational system where HAZ-MH is, and over here you can see the main data inventory folder where originally Hazus datasets are stored, and over here are our outputs, aggregated data and OpenStreetMap points, and our data which we will have overwrite. And right now we will do that. It will take some time. I apologize that my computer is so slow and it will take some time. Right now it copied over here, so this inventory right now is empty, but over there are Lithuanian datasets, but we should not forget that we acquired the aggregated data and the essential facilities. So what do we need? We need to integrate them in our inventory. So right now we will use the same methodology which one other Hazus users in the United States use. So we use the CDMS. This tool comes together with Hazus, and it is dedicated to import various datasets into the inventory. And what we will choose over here, import the CDMS from the inventory. Over here you can see the bigger screen. And first of all we will start with the aggregated data. So we will see it's over here. So we will choose over here and aggregated data, and as I remember we had the demographic by census blocks. So we choose. Or here's the table, demographic count by block. Everything is very fine. And now we have over here the data match field. That's where we will match the field. Okay, over here is total census tract population. Over here is the mistake left by the creators. Officially, this should be total census tract population. So I hope in further versions they will correct this. So we will take this population, we will match it with our grid code where our population is. We matched and we click continue. It can take some time if there are a lot of level 3, in this case, census blocks. And over here's the question: do you want to roll the data up to the tract level? So I would recommend to choose yes. Then there will be no need to add level 2 demographic data. An example of demographic data can be used in the earthquake and the hurricane models, but in this case it will not be useful. So over here we have data already prepared to be integrated into the inventory, and we can just simply transfer them. It can also take some time. Also over there is, I noticed the problem that if you have more like 9,000 records, there is the problem over here in the reports as an error. And so in this case I would recommend to integrate, split it by parts. I'm not sure in the newest CDMS version, but in this it occurs. So we integrated the population data. Now we need to integrate the essential facilities. There will be some more time consuming work because we have various types of essential facilities. I will show you in this presentation only one, but I will integrate them all. I will save your time. So we will choose now some points, and over here we will choose shape files, and because we choose schools over here we also choose schools. It's thinking. Over here we will choose that no Hazus ID is available, and over here there is one field from the Openstreetmap amenity. It means the class of the facility, so we can match this one over here. In this case, in HAZ tools only for schools, it is possible to, because schools are few classes. Example, we have universities, we have the colleges, schools, kindergartens, and I define the amenity to the facility class, so we will just click match. In other facilities it's automatically. Over here we have the CDMS prompt that we do have some additional attributes like the structure damage, function, building type, and so on, because they are not available such properties from the Openstreetmap, so we will choose them as a default and as defined over here. If we would have this, then the data would be more accurate and then we would get more detailed analysis, but we have what we have and there's nothing we can do now. I will choose yes, and now we will categorize some fields which I mentioned before. It's a facility class. So example over here, the grade schools I will define to the kindergartens, the schools as a default school, the university is here, and the college is here. And we have more detailed information. And it reports that the data is important in the repository, and we will import them. Okay, so now I will import another 4 types or 3 types of essential facilities, but I will not show them over here by saving your time. So over here in the history you can see the school facilities which I showed you. Also I integrated fire stations, 3 fire stations, fire healthcare facilities, and 5 police stations. So right now we have everything in our inventory. Now what we need to create the new study region. I can minimize this. And I think, did you remember the view when we were first using the default region, and then you were able to see the United States over here? We will see what we will be able to aggregate. So we will choose census tract, and so over here instead of United States you can see Lithuania, and over here we will choose Vilnius district, and I'm not sure which tracks should be over here, so the capital city, so I will choose to show the map. I'm not sure, it's number 48. Let's see. Yes, I'm correct. This is 48. So now I will wait until the new region with our population data, with our essential facilities, will be created. When we get information that the region was created, just click OK, and now open the region. There's the latest one. Let's check what do we have over there. It also can take some time until it will be opened. And when it will be opened, it will contain all inventory data. So far no flood hazard data. Right now we will be able to visualize our inventory data, so the population grid and the essential facilities, and that will be what we will try to do first. So let's see, over here we have this area which we have chosen, and let's see our demographics. So we have the population, you can visualize it, and we have nice population grid. So where is our inventory essential facilities? We can visualize first the Medicare facilities, then the fire stations, police stations, and the schools. Also, as you can see, all the default information, the costs are default, but it's for sure it's recommended to have the costs, because for that case we can make the damage destination express in monetary value. So the main facilities are located over there. So right now we have the inventory data, so the second step is we need the flood hazard data. Over here we select the type riverine only and user data. In HAZUS there are a few possibilities to deliver the flood hazard data. First possibility is to integrate the DAM, and then using the regression equations. First the stream network will be generated, and then there will be chosen two possibilities: to use regression equations for hydrological analysis. If they are not available, then the user can input directly the discharge values and then go straight to the hydraulical analysis. And the output of hydraulic analysis will deliver us flood depth grid. Second possibility is to use FIT, flood information tool. It comes together with the HAZUS. Over there, from the hydraulical analysis, you get the boundaries and the other parameters of the river. I think cross sections, yes, the cross sections of the river. Over here you can input the depth grid directly, example from another tools like HMS from Hydraulic Engineering Center or wherever, or other 1D or 2D depth groups, it's not matter. Also over here you can integrate the directly from the HAZ-I. Because we don't have the flow depth grid, so anyway the first task for us will be to acquire the DAM. So let's get back to another operational system, and over here I have I have the great website where you can download many types of digital elevation models. Also my favorite Aster DAM, and simple to use. So I will just navigate to the Lithuania. We have over here, and the quite important is that the coverage of the DAM would be sufficient for studies, so it's better to wider area. We can zoom more in. And I will select as a polygon feature. This DAM, as I remember, is 30 meter resolution, and all the time it is updated. It's not loading anymore, so I will choose something like this area. I hope it will be enough, and then I just download. You need to log in, but it's free. And I would recommend, instead of GeoTIFF, I would recommend to download tiles by tiles. Right here. We will get the link and we download them and extract them where it's more comfortable for us. I just downloaded the DAM, and now I will browse user data, and over here, and I will choose all of these one by one, and then I will click the OK to generate the DAM. After 11 minutes we got some smooth DAM, and as we notice over there's the river bed, and some of the police stations and the hospitals are near this area. So the second step will be to develop the stream network, and let's set the 5 square miles, and this also will take some time. This operation is analogical as with hydro tools, which are known quite well. After 15 minutes of analysis, we got the stream network, and we are lucky that it goes over here where it should go, and we can see the whole stream network over here. Take some time to load. Yeah, but now what we will do, we will choose the new area, and we will select the reaches all of which are important to us. Holy cow, it's quite slow. So I will select this one reach, and let's identify it, and also I would like this one. So 2 reaches, I save it. And now I will delineate eliminate the floodplain, I will go straight to the hydraulic analysis, and instead of single return period, I will choose the single discharge, so I choose even 4 reaches. And example, right now I'm not sure how high is the discharge peak in these reaches, but example, you can get this data from the hydrological analysis, example HAZ-MS, or also from the various sensors which are located along the river streams. And over here I will just input maybe let's try 20,000 cubic feet per second. Oh my goodness. And so it will generate using these inputs. The Hazus will generate the flood depth grid. So it will take also some time. And finally we finish with the analysis. So over here you can see the flood boundaries. I will zoom in, and it can be that no essential facility is affected by the flood. For this presentation it's not good, but in general case it's good. And I can run the analysis right now. What do we have now? We can run for all essential facilities, and we can run for the shelter because we have population data. So I will run it. It should take a few minutes. So the analysis took about a minute. Now we can check the results. And looks like I was right. No medical care facilities, no fire stations, and no police stations, and no schools affected. But we should have the displaced population. Yeah, over here we have displaced population. And looks like the 20,000 cubic feet per second were not enough as the input to generate quite big flood. But from another case, essential facilities are not located in the floodplain, so they're not so affected by the floods. And okay, so you can see that over here the displaced population is about 321. Over here is 175, and so on. Also, we can get some reports. Like shelter requirements, the same displaced population. Take some time to generate the report. Over here at all, number of displaced people in the case of this flood. So that was the practical presentation. Thank you very much for your attention. And also we should consider, as I mentioned before, that as more detailed information we will provide as inputs, as more detailed analysis and more efficient analysis will be. Now it's time to conclude our research, and the very huge advantage is that our introduced tools and methodology don't change the whole assessment framework in the HazusMH. So it means that the same tutorials, same guides, same courses can be used to train the HAZ users in all the world. And our introduced tools and dataset enables to create any region and perform flood risk assessment using HazusMH only in few steps. It's quite simple, and our aim was to introduce these tools and to make them efficient that there should be not much interference of the user. And also the increasing use of the volunteer geographic information systems brings the GIS into new perspective. And also some of us, we could think that the information from VGI services is not worth to trust. But if someone had the experience with the default Hazus datasets, and when dealing, example, with essential facilities, then according to my own experience from Indiana and Illinois states, only about 5% of all essential facilities were in correct place. So it means that even the default dataset, where a lot of users I think that it's very correct, it is false and it's not correct. And example, I tried to compare the default Hazus dataset with the VGI information, and VGI information was quite more precise than the default Hazus datasets. And so over here is only the question how this information should be trusted, and that should be considered by the user for sure. And the combination of HazusMH, evacuated tools, and VGI enables small communities around the world to mitigate disasters with a minimized financial expenses and human resources. We all know that the flood modeling and the risk assessment is quite expensive activity, as we could call, and but these tools which we presented and methodology together with HazusMH and the VGI, it enables the small communities which don't have the money, don't have the experienced experts to do some minimal risk assessment and to raise the awareness between the people in the communities. And I think it's quite important thing, especially in the developing countries. And if this methodology and these tools all together would get more popularity and availability, I think that then more scientists would be focused to develop the existing methods and for sure introduce the new ones which would be able to improve the methodology and for sure bring the safety to our lives. And the success of internationalizing Hazus flood model brings us the motivation to continue the research toward the internationalizing the Hazus earthquake and hurricane models, because the inventory structure is the same. So what we need only to work. And the future work would be first, I think of all, to find out how it would be important for international community to have the internationalized Hazus earthquake and hurricane models, and if they are interested, then we could focus on that thing. Also, it's not a big issue to create the Openstreetmap tool to download the user-defined facilities in transport and utility facilities, which would be quite good benefit to the flood risk assessment with Hazus. Also, we are still thinking about developing the worldwide regression equations, which would enable to perform the hydrological analysis inside the Hazus. And also, we are planning to enhance our presented flood depth grid producing methodology, which was presented in the last presentation. And also, we are thinking to simplify the methodology of integration of hydraulic engineering center tools as inputs to the flood hazard analysis in Hazus. And also the user-defined facilities right now in Hazus, they are not very functional, so it means that not many reports or not detailed information as a result from flood risk assessment can be gathered from the analysis. So what we are thinking to develop the functionality of the user-defined facility results and to improve the reports. There are still a lot of space for improvements. And also my plans are to continue to developing the web-based platform. I called it Flood Risiko, and to visualize the Hazus outputs with the support of web mapping service. So it would be more focused for the small communities, which would be able to observe the results of the Hazus flood analysis and to see them through the internet, and also maybe in the future event to make an inputs to the Hazus. So and in the end, I would like to say big thanks to many people who contributed this research. Especially big thanks to my supervisor Gernot Paulos from Carinthia University of Applied Sciences, Austria. Also my external supervisor and good friend Kevin Mickey and all his colleagues from the Polish Center, where I stayed in summer 4 months. Also big thanks to Peter Zeil, who raised my motivation to get interested into the floods about 2 years ago. Also Nikolai Todorov from ABS Consulting, United States, and many other people. Without you, we would not perform this research. And also over here at the bottom you can see few links of the past presentations. And also over here in the end I provide the contacts for questions. Do not hesitate and ask any question if you are interested. We always are looking forward to cooperate and work together with private companies, agencies and communities, no matter from which country they are. And we also are looking forward always to implement our research and to apply it practically. And I think no one should forget that only the cooperation and work together will help us all to improve, to save the lives and property. Thank you very much.